Hello again. Today we're starting the solving part of our unit here. The directions say solve on the interval from 0 to 2 pi. Now remember, when we have directions that say solve, it means find the number or numbers which, when put in place of our variable, makes the equation true. So, which angles will make this equation true? Now our strategy for doing this is going to be to isolate this trig function here. To do that, we'll add 1 to both sides. It's 2 sine of theta equals 1. Then we'll divide both sides by 2 and get sine of theta equals 1/2. So then we want to know which angles make this equation true. Which angles have a sine of 1/2? So let's draw those out. Sine of 1/2, remember sine is y over r. Y over r. So this angle right here is going to be a 30-degree angle, because it's a 30, 60, 90. So one of them is going to be 30 degrees. The second angle is going to be from here to here, which would be 150 degrees. So 30 degrees is pi over 6, and 150 degrees is 5 pi over 6. Next one. We want to again isolate our trig function, add root 3 to both sides, and then divide both sides by 2. And then ask ourselves which angles have a cosine of root 3 over 2. So cosine is x over r. So our x will be root 3, and r will be 2. Now notice you could also have a reference triangle down here with an x of root 3 and an r of 2. Difference being is that the y would be -1 on the second one. So then, this would be a 30, 60, 90 triangle. 30, 60, 90. Same sort of thing down here. And so, here we have a 30-degree angle. And then here, we've got a 360 minus 30, which would be 330 degrees. So our two angles then would be 30 degrees, just pi over 6, and then 330 degrees. Change that into radians, you get 11 pi over 6. So those are the only two solutions from 0 degrees up to 2 pi, which is 360 degrees. Now the next set of problems are more difficult because it just says to solve, meaning it wants us to find all the angles that make these equations true, not just the angles that are between 0 and 360 degrees. Alright, so this first one. Look at this and see this looks like a quadratic equation, because basically this. So we can take a quadratic equation and we can factor it into two binomials. We take sine of x and put it in the first spot. Then I would put, so I see a minus 2 here, so I'm going to do a minus 2 times a plus 1. I could mentally FOIL that out and see if it works. Got sine times sine is sine squared. Outer product is plus sine x. Inner product is minus 2 sine x, and when you combine those, it gives us the middle term. And last, minus 2 times plus 1 is minus 2. So it checks. Alright, so then let's set each of these factors equal to 0 and solve. Okay, first one, I'm going to add 2 to both sides. Sine of x equals 2. Next one, I'll subtract 1 from both sides. Now look at this and I say, what angle has a sine of 2? Now remember that the sine graph, highest that the sine graph goes in terms of its y values, basic sine graph, is positive 1. Never reaches positive 2. And so for this one, unfortunately, there's no angle that has a sine of 2. And so we can just ignore this one. Boom, right here. Next one. Which angle has a sine of -1? Now remember that the sine graph does go down to -1. It's -1 at 3 pi over 2 when we do out our graph. So I know that it's going to be 3 pi over 2 is going to be one of the angles that makes it true. But as we know, this sine graph repeats. It has a period of 2 pi, and so it's going to hit a -1 here, and then farther down, etc. It's going to hit that angle at every multiple of 2 pi after 3 pi over 2. Because remember, the period is 2 pi. So we need to add on every multiple of 2 pi where k is an integer. Alright, so this next one. We want to isolate our trig function. So we're going to have the sine of some 3 theta angle equals 1/2. So I know that, back from the earlier problem, there's 2 basic angles that have a sine of 1/2. And that is pi over 6 and 5 pi over 6. Now, I see that it's 3 theta that equals my angle, pi over 6, and 3 theta that equals 5 pi over 6. So what you need to do then, when you've got these numbers being multiplied in front of your angle, is you need to divide both sides by, in this case, 3, in order to get rid of that 3 there. So we see that our actual angle is going to be, divide both sides by 3, and you get pi over 18. Divide this both sides by 3, and we'll get 5 pi over 18. Now remember that we need to find all of the angles which make this true. So this graph right here, if we were to graph it, would repeat at a certain period. Now the period that we need to add on is going to be different than this 2 pi k, because this 3 messes things up. What you're going to need to have to remember is that you take our b number, which is 3, and to find the period of a graph, you need to do 2 pi over b. That's something that we did in the last unit. So in this case, let's do 2 pi over 3. So this is going to be our period here. So in order to find all of the solutions, we need to take this period and factor it in for both of these angles. So for one of the angles, we're going to have pi over 18 plus the period of our graph times k, where k is an integer. And then we're also going to have 5 pi over 18. Let me scroll so my camera video isn't blocking you. Plus the period of our graph times k, where k is an integer. Alright, last one in this section is cosine of pi over 4 theta equals -1. Now this cosine function is already isolated, and so we can take a look at our graph now. This is a quadrantal angle, because it's a cosine being 1, 0, or -1 value. So we remember the cosine graph. We see that, alright, traditional cosine graph, basic cosine graph, has a y value of -1 at pi radians. And so this pi over 4 times theta is going to be equal to pi radians. So then to find out what theta equals, we'll need to divide both sides by pi over 4. When you keep change flip, you're going to see that theta equals 4. Now remember, we're going to need to add on one of these period factors like we did in the other examples. So we need to go plus some period factor. What's the period here? We do 2 pi over b. Keep, change, flip. Those pi's are going to cancel out, and it's going to give us a period of 8, which then we need to multiply that by k to get all of the multiples. And that's going to be our set of solutions for that one. Next up. On this one, I think I put a note in the paper copy of your notes that we're going to need to use a calculator on these. So first thing then is we'll isolate our trig function. It's going to be 2/7 there. And then we want to find which angle has a sine of 2/7. So we want to get out our calculator, and using your calculator, I'm going to write this over here in red. Do the sine inverse of 2/7. And I put a note in your paper notes that this should be in degrees. When you do that, it's going to give you approximately, let's get this to 4 decimal places. Approximately oops, my calculator is in radians. That's a problem. Let's switch this one to degrees. 2/7. And we are going to have an angle of 16.6015 degrees. And so 6t for our first angle is going to be approximately 16. 6015. And then divide both sides by t, and we're going to get approximately 2.7669 degrees for our t. Now, we need to find the first 2 positive values for x, or for t. I think I changed your notes to say t. And so what we need to do next is we need to figure out what the period of this graph would be, and then add that on to this, and we're going to find then the second value. So remember that regularly the period is 360 degrees. And so instead of doing 2 pi over b, which would be the radian way to do it, we're going to do it the degrees way and do 360 degrees over rb, which means that the period of this graph is 60 degrees. So then we would add 60 degrees to that answer, and we would get 62.7, erase that, 7669 degrees for our second angle. We'll also circle our first. This next one can be done at the beginning of our next class, and I'll see you there.